Binomial probability is only a certain kind of probability. It is based on or comes from binomial expansion. Do you remember how we found the coefficients a couple days ago when we were expanding binomials? What did we do? We used combinations to do that. So what's going to happen with binomial expansion is it's going to involve some combinations, and I'll explain why. Binomial probability is a kind where there's only two outcomes. So for instance, let me give you examples. On the back, I put an at bat. At bat, you either are going to get a hit or no hit, okay? Or if you're shooting a free throw, you're either going to make it or you're going to miss it, okay? Or when you're tossing a coin, either it's going to be heads or it's going to be tails, okay? So it only is when there's two possible outcomes. And I'm going to just go through what we call those things. We're going to call P the probability of success. Okay, now let me talk about success. Success is just the thing you're counting. So you might want, like in a second, when you do your homework, you're going to see something about defective calculators. Now, you might not consider a defective calculator a success, but it's the thing we're counting, okay? The other thing we call Q. And so that's going to be the probability of failure or not success. And you're going to always get Q by taking 1 minus P. I hope that makes sense. If there's only two probabilities, don't those two have to add up to 1? Okay. And finally, you're going to see an N, and N is just the number of independent trials. Okay, so I have this chart for us to fill out, and then we're going to work on some. So on this side, what this represents is the number of successes of n trials. And over here, we're going to write, how would you calculate the probability? Okay. And we're going to just kind of write a little table, and then I'll talk about the second example on the back. Okay, so first of all, if there are 10 trials, isn't it possible then there are 10 successes? Okay, so in n trials, the maximum number of successes is n. What that would mean is the probability of success, which is P, would occur all n times. So we raise that probability to the nth power. Okay? And there's only one way that can happen. If I, in a game, shoot 10 times, and I make all 10, that happens one time. There's only one way that can happen. Okay? But let's say I go to the free throw line and I make only 5 of my 10 shots. Aren't there different ways that can happen? It could happen on the first 5 or the last 5 or some mix in between. Does that make sense? Okay. So then let's go to, let's say I make 1 less the number of trials. Then that means I failed how many times? If I have 10 free throws and I made 9, that means I didn't make one time, correct? So what that means is you still have your P, you raise it to the n minus 1 power, but now you have to write down the probability of a failure and raise it to the first power. And then I have to count the ways that can happen, because there's a lot of different ways that I can miss one shot. The way that I count that is a combination. So I'm going to put that long parentheses in front. Okay. So I'm going to do a dot, dot, dot to just say that the pattern continues. In the middle, I'm going to put a general term. So in end trials, in general, if there are R successes, the way we figure out that is we take NCR times we raise the probability of a success to the R power, and we raise the probability of failure then to the difference of N minus R, because that's how many failures would occur. So I'm going to highlight that formula because this is the general formula that you're going to see for binomial probability. Okay, but let's just kind of go through the list again. I'm going to do dot, dot, dot. All right, continue on. Let's say there on N trials I only had one success. How would I count the ways that would happen? NC1. What letter represents the probability of success again? P. So I only raise P to the first power because there's only one success. And that means I would have whatever the difference of N minus 1 would be, that would be how many failures I would have. And then finally, it is possible to have no successes. And now technically I should write NC0 here, but think of Pascal's triangle. What was the first number always in a row? 1. So I'm not going to write NC0 down because it's 1. Okay, there's only one way it could happen. And that means if there are no failures, technically, could I write P to the 0? Sure, but I'm not going to write P to the 0 because what's P to the 0? 1. I'm going to just write, if there were no successes, that means they were all failures. Okay, so I think that I haven't looked at Miguel Cabrera's batting average this year. Plus he's on the DH, right, till tomorrow? DH, I said that wrong. DL, till tomorrow. Get my things confused, my letters. This is last year, so at this time last year, that's what his batting average was. He wasn't hitting very well last year at this time. So we could do it with anybody's batting average, but this is really a good example of binomial probability. So when he gets up to bat in a game, the number of at-bats is his trial. So let's say he gets up to bat 4 times. That means he's got 4 attempts. This is my N. Okay. What's the probability of a success then? .282. That's going to be my P. Can you guys figure out Q for me? So yep, it is 1 minus 0.282, so it's 0.718. Okay, so I know my N is 4, I know my P, and I know my Q. Let's apply it to 3 hits. What's the probability that he would get 3 hits? So how many trials are there? 4. This is the number of successes. This is like my R in the formula. So I have to first count the ways. That's going to be 4C3. Because there are different ways that he can get 3 hits in 4 at-bats. Then I have to see how many successes there are. So there are 3 hits. So I take the probability of getting a hit, which is 0.282, and I raise it to the 3rd power. If he gets 3 hits, that means one time he does not get a hit, correct? So then I have to multiply that 0.718 to the 1st power because it's only getting a hit, or not getting a hit one time. All right. Hey, what is 4C3? Who remembers? Nope, it's 4. 4C4 is 1, 4C3, the one before it is that. If you don't know, just type it in, but I'm going to save some time. Okay, so the probability of him getting exactly 3 hits then, based on that average, is 0.064. Okay, now that I've done one, help me out with B. How would I do it? This is exactly 2 hits. What would I do first? 4C2. Good. There's 2 hits, 0.282 to the second. But that means that there's 2 times that he doesn't get a hit. All right, would you calculate that for me, please? What do you get? .245. What comes after the 5? Okay. So this is exactly 3 hits. The probability he gets exactly 3. The probability he gets exactly 2. Let's talk about something like this, okay? And I'm going to, if this happens where you get at least, what you have to do is add all the cases together. But I want to point out something to you. At least 1 hit would mean 1 hit, 2 hits, 3 hits, or 4 hits, correct? All right. Would you agree with me? The entire distribution would be P of 0, P of 1, P of 2. Isn't that all the things that could happen? What should this sum of this be? Just based on what you know about probability. If I added these together. Right? What might take less time than going through and figuring out 1, and then adding it to 2, and then adding it to 3, and then adding it to 4? What would take less time? Couldn't I figure out no hits, and then subtract from 1? Wouldn't that take less time? Okay, now you are more than welcome to find this, especially since we found 2 of them already, and add them together. But since we know that the entire distribution adds up to 1, what I am going to do is instead, I'm going to take 1 minus the probability of no hits, because they are going to equal the same thing. All right, so the probability that he would get no hits, what that would mean is I could do NC0, but I said let's not do that, because what is NC0? 1, so I'm not going to write it down. This would mean P would be raised to the 0 power. Do I need to write that down? No. This means that Q, if he gets no hits, that means that Q, 0.718, happened 4 times. Okay. So you can see that is rather high then, even based on his batting average. That the probability in the next game, even with a batting average of 0.282, that he gets at least 1 hit and at 4 at-bats is 0.734. Okay, so do you have questions on those?